Hey, boys and girls, it's Mr. Mac. Today we are working on Module 5, Lesson 1, which would be using unit cubes to build solid figures. So if you don't know what a unit cube is, just think of a cube that measures 1 unit by 1 unit by 1 unit. So what does that mean? Let's look at a picture of a cube. So I'm going to draw a cube right here. Three-dimensional, right? All squares on each side. Okay, this is my 3D cube. It may not look like much, right? But it's a square, three-dimensional. So every face, every side is a cube. A unit cube means that the length, which is how long the object is 1 unit. Now, a unit could be inches, feet, yards, miles, whatever measure, a unit of measure we're talking about. So this is 1 unit. It's the same unit on this side as the width, because it's a unit cube. In a square, the length and the width are the same. And then we have the height, how tall it is also that same unit, okay? Now, we call it a unit cube because it could be any unit, like I said before. So if we're dealing with feet, it would be 1 foot long by 1 foot wide by 1 foot high. That's one of the biggest things to understand when we talk about unit cubes. You may have played with them before and had them in blocks that you connected, and you would say 10 of them makes a long, and things like that. But we are going to be using those today to build some figures in different kind of ways. So when we're looking at solid figures, we're going to be talking about right rectangular prisms. So this picture we have is of a cube. A rectangular prism I'll draw over here is just like a cube, except the faces are going to be rectangular. So this is what I have here. It's very rough looking, I apologize, but that is what a right rectangular prism is going to look like. It's kind of like a tissue box, right? We've seen ones that are cubes, but we've also seen ones that are rectangular, like this object, right? This tissue box would be an example of a right rectangular prism. So we're going to work on doing those and building those today. So in our example that we're given here, it says Alexandra is volunteering to stack boxes of soup cans at a community food bank. She stacks the boxes to form the right rectangular prism shown. Make visual models to show 3 other ways that Alexandra can stack the boxes to form right rectangular prisms. So when we look at the picture of Alexandra that Alexandra has here, she has, if we count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, she has 12 boxes. So what she did is she made 2 rows, and each of them had 6. Well, what we want to figure out is how could we use 12 total boxes in order to make a different shape rectangular prism. So if I'm looking at the length, the width, and the height of that stack that she created, all right, I'm looking at how long this is, which it looks like it is 6 boxes long, 1 box wide, because there's not more than 1 row, and 2 boxes high, okay? That is one way we could say, okay, there are 12 total boxes with the length, width, and height there. We're looking for another way to have a different length, a different width, and a different height. So if you want to pause this video and try and create another way, feel free to do so now. And now that you've unpaused the video, you may have found a result and you may not have found a result, okay? But if I was drawing a picture, I might draw 3 boxes this way and then 4 boxes this way. So that's 2. Oops. Okay, and now this would be 3-dimensional, obviously, but this is what we would see from the front, which would still be 3, 6, 9, 12 boxes. So I might have a length of 3, a width of 1 still because it's only 1 row deep, and then a height of 4. That's what we're kind of talking about today when we talk about building different right rectangular prisms, but using the same amount of blocks. It's almost like if you were to use Legos or any blocks that you have, or if you have other siblings that use those blocks, it's almost just like taking those, and here's 12 blocks, find a way to make a rectangular prism with those 12 blocks, other than the one that was shown as our first example. Okay, so here's another example that is also in your workbook. It says Carlos and Kelly are building store displays in the shape of right rectangular prisms using cube-shaped boxes of the same size. Use unit cubes to make visual models of the two displays. So if you have cubes or anything around, you could do exactly what they did. Okay, you can see that Carlos has two boxes here, and then there's also two behind it. So there's 4 on the bottom, and then 4 again, 4 again, and 4 again. So it looks like there are 4 rows of 4, whereas Kelly has 1, 2, 3, 4, and then there's a row behind it which has 4 more. So there's 8 on the bottom, and then the second row has 8 on top of it as well. So when we're talking about how many cubes are needed, both of them actually have the same amount. It's almost like we took Carlos's display and laid it flat on the ground to look like Kelly's. They may look a little bit different, right? But they still have the same amount of unit cubes to create their displays. Carlton has 16 boxes, and so does Kelly, all right? So the answer to that one will be 16 in each. So now it says, think of the length of the edge of each cube-shaped box as 1 unit. What are the dimensions? And when we did dimensions earlier, that dimension is just talking about the length, the width, and the height, okay? So let's look at that and say, how long is this object? Well, it looks like it's, the first one is the length. Actually, let me use a text box. Okay, our length in our box here, okay, the length is going to be 2 units. The width is going to be 2 units, and the height is going to be 4 units. Now, when we look at this example, how is that so? Well, again, there are 2 on the bottom going across, and there are 2 on the bottom going back. So that's our length and our width. The height is how many boxes tall is it? And it's 4 boxes tall. Now, if I had to do the same for Kelly's display, I'm looking at her length here, and I'm saying, well, her length is 1, 2, 3, 4 boxes. Her width is 2 boxes, but then the height is only 2 boxes there. So that kind of gives both of Carlos's and Kelly's displays dimensions, right? So when we talk about their dimensions, we have the same numbers. It's just organized in a different way. Now, they're not always going to be the same numbers, but just for a further lesson, to find the volume, if you multiply those numbers together, length, width, and height, that will tell you what the volume is. So 2 times 2 is 4, times 4 is 16, or 4 times 2 is 8, times 2 is 16. And we'll get to that again. Today, we're more about counting those cubes. All right. When we talk about vocabulary of unit cubes, we've talked about the length, width, and height. We also want to talk about 3 really important vocabulary terms, which is shown in the Connect to Vocabulary section right on the side here. It says a cube is a type of right rectangular prism. A unit cube is a cube that has length, width, and height of 1 unit, right? But then we have the faces and the edges. The faces, like if your head was a cube, okay, your face is the big parts of the cube, right? That's the face. The edge is the spot where 2 faces meet. So if you think about a cube, if you think about even a tissue box, all right, we have a face here, and even this would be considered a face. We call it the top usually, but it's the face. Where the faces meet, this line is like an edge. And I always call it like an edge because if this was something where somebody was walking on it, and you'd get to the edge and you would stop, because if you went over the edge, you would fall. It's just like a mental idea for me to remember the vocabulary for a unit cube. So the question is, how many faces and edges does a unit cube have? So looking at any cube, again, I have a tissue box. I know it's not a unit cube, but I have other items that are here that are cubes. I need to think every unit cube, no matter what, has a front and a back, so that's 2. The sides, that makes 4. And then the top and the bottom makes 6. Okay? The edge is, if you're drawing these unit cubes, usually the edge is how many lines that you have. Well, I know if I'm counting the edges, and it's easier sometimes when you have these picture of a unit cube. There's 4 edges on top. There's 4 edges on bottom, and then there's 4 that are on the sides. So that would make 12 total edges on a unit cube. All right. Now, when they ask about how many edges, faces, and everything else each of these displays have, if you were to count them, it would be the same, right? You would still have the same amount because it is a right rectangular prism. And a cube, if you take a cube and kind of just widen it out, it's not going to change the amount of faces or edges that are there. So unit cubes and right rectangular prisms have the same amount of faces and edges. All right. So now for the last question, it says, how can you place Carlos's display to make it match Kelly's? You just lay it down, right? That's all it is. You just lay it down. It doesn't matter if the shape looks like my tissue box here, or if I turn it on its side, or I turn it this way, or I turn it this way, or any way I turn it, it still is going to be the same amount of space taken up. If it was made of unit cubes, it doesn't change the amount of unit cubes that we are using. So a big part of this lesson, besides just creating right rectangular prisms that are the same, a big idea is also just counting the unit cubes that are in these figures. And sometimes there are unit cubes that are being used that we can't see, and we have to kind of think about real life situations of where those unit cubes are coming from. So when we look at question number 1, we can see all the unit cubes here, right? We have 1, 2, 3, 4. We have 5 of them because there's 3 on the side here and then 2 right there. So that's 5. Number 2, we look at number 2, and it's clear that we have a big cube here, right? But we can't see kind of behind, but we have to assume, right? These cubes just can't be floating in the air, right? We have to know that just by looking at this picture, and I'm going to squint and get really close here, we've got on the bottom 1, 2, but there's also a back row. So we have to assume if there's 2 in the front, that there's also 2 in the back. So that makes 4 on the bottom row. And then you can count from the top that there's 4 more. So that would tell us that there's a total of 8 unit cubes for example number 2. When we look at example number 3, same idea. We can kind of see all of them. So we count them, and there are 5 there. So when we talk about which one has the greatest number, well, obviously numbers 1 and 3 had 5 blocks. Number 2 had 8. That's going to come into play when we are talking about volume, which is coming up in this module, okay? On these check for understanding problems, I just want to make sure you understand. No pun intended, right? Same on number 2 is just like number 2 up top here, the red blocks. You have to figure out how many rows there are. So if you look here, you can see there's on the bottom, there's 2 rows. So every time you see a block on the bottom, that's really 2 because there's 1 in the front and 1 in the back. So this would be 2, 4, 6, 8, 10 on the bottom. And then again, there's the same amount on top. So 10 and 10 would give you 20 unit cubes. All right, so that's the big idea of today's lesson. And it's a start for us talking about volume and doing a little bit of geometry work in Module 5. All right, best of luck with today's lesson, guys. Take care. Stay safe.